I thought maybe the best way to look at what Art API can do is to compare it side by side with the current search capabilities and what is now possible with Art API. So to the left, you will see the current collections portal built by a third-party vendor. And if you were to look for things like people, right, you'll notice that if it's not in the title or any of the other current metadata about this stuff, you won't be able to find it. Right, so obviously we know that there certainly has to be more than 103 paintings about people in the entire collection of close to 10,000, right? Because people is a super popular category to be painted about. And now let's take a look at maybe whether things are better on the Roots portal. And if you look at other Roots as well, which I've already done a search and let me take you to the galleries collection, actually the same thing happens. If people is not mentioned anywhere, you won't be able to find it. And of course, in a way, they have a bit more data, right? Is in the description of the artwork, which also does lead to some inaccuracies as well. Because if, for instance, in this case, it's just fruits that local people like to eat, breakfast, it gets returned as a result as well. So to the right then is what we have actually built with Art API, which is capable of predicting certain attributes in artworks. And we have focused on color and objects in particular, right? Because these are objective enough as a starting point. So as you can see here, when you look for people or when you select for people, what this app does is then it returns you all the artworks that are predicted to have people inside. And I think what's really cool about training this on art data is really that there's such huge variation in the way that people are depicted, and still we're actually able to pick them up, right? Whether it's in a sculpture or whether it's like these different forms of and styles of art, like this sculpture over here, and even this series of lines. So it does point to a potential for us to use art as a form of data to build probably what could be the world's best censorship machine for nudes, right? So yeah, and maybe let's take a look at another category that actually predicts really well in our model, say boats. So while waiting for this to be ran, as you can see, we're actually calculating this in real time, and this code can actually be optimized further. Let's take a look at what happens when you look for boats on the current portal. And you have 66 results. And again, if it's not already in the title, you'll be able to find it. But this is, again, highly counterintuitive because you imagine that there's lots of paintings out about boats, especially for the National Collection of Singapore. And what we have here are, I think again, what's so interesting about this is the fact that we can pick up an object regardless of how it's depicted, right? You kind of like Chinese ink and you have photographs and so on and so forth. But we're actually able to pick out most of them pretty well. So boat also predicts really well. And just one thing before I move on to colors is actually that all these objects that you see over here, from airplanes to trains, these are actually existing categories that I found in probably the only data set in the world that has annotated artworks with objects based on Art UK collection. So both people and building are actually new categories that are created by scraping images off Google, and in a way creating my own training data for the machine to learn to identify these things. And there are also categories that do not perform quite as well. For example, birds, right? This may have to do with the fact that birds generally are really small. And what I want you to pay attention to is actually what the machine does pick up along with this category of birds, to identify a pattern in what is returning us. So if you look at this carefully, I think the curious thing here is that actually most of what is being picked up appears to be nature, right? And you do get some like calligraphy thrown in here and there as well. It even picks out a chicken as a bird, which is actually a pretty good result, I guess. But I think the idea that the machine is getting at here is really that actually if we have more categories and again more training data, our AI can get even better, right? And then for some of the results that may be false, there are also ways to deal with that, which I'll go into after I talk about color as well. So okay, you will have birds. And then now let's take a look at color. So the interesting thing about color is it's actually a very complicated. So the interesting thing about color is actually that it's a much more complicated problem than we imagine. And there are quite a few optimizations that can be done here in the sense that depending on how you define that threshold, whether you define it to be 10 or 100, for instance, when you look for red, it may return you something that is further outside of red or super close to red itself, right? Depending on how you tune that threshold. But the unfortunate thing is that there's really no sort of standard for how you define the threshold for different colors at the moment. So you pretty much, in a way, have to use your eye power effectively. But for the most part, this does seem to look mostly red, right? And then now let's take a look at, say, yellow. So essentially what we're doing in the background is actually whenever the user looks for a certain color, we're trying to calculate the color distance, the color difference between the color they're looking for and whatever color values that was extracted for a particular artwork. And then we return it if it's within the threshold that's been set. So yellow also seems to work, right? And again, depending on how you tune the sensitivity of these things, sometimes like very, very light yellow could also get returned. You will see a lot of paper, a lot of works with paper in them returned as well. So obviously in the future iterations, you could also try to tune the AI to also maybe ignore backgrounds, right? So stuff like that. So I've shown you that we are now capable of predicting colors and objects, and we can actually build up that entire list of objects based on whatever training data that we might want to add on to it by scraping images off Google. I think the long-term potential for this, actually it's not even long-term, it can be done immediately more or less already, if you have a team of people working on it. But essentially what we can do is actually just return some of these predicted labels to the user, right? Actually ask the user to help us verify or correct some of these labels. So I also talk about how we can actually invite the users to be part of the process to help us correct these records to be our ground truth labels, right? So all we need is actually an API that allows us to create this text, read this text, update this text as well as delete them based on what users tell us. And you can even programmatically on the back end, right, say that, okay, if two independent users provide this similar set of text for this particular work, and once a certain threshold of number of correct ground truth labels have been given, we can automatically retrain our model and then push that to be served live. But anyway, so I have built a very simple API that allows us to do that, and it just needs to be integrated into the interface, right? So for instance, maybe the user spots a dog and a horse, and I don't know, maybe ice cream in the artwork as well. And as you can see, this is actually created. So when you batch the list of records, that was what was just created, right? ID number 3. We can also edit this thing. We can edit it to say cow instead, right? So you execute, and now the third response is actually tagged as a cow. Let's see if it's updated. Yes, it's updated, right? So you can also do delete and so on and so forth. But I think you get the gist of the idea. So in conclusion, what we have done is to predict certain attributes in artworks, specifically color and objects using artificial intelligence, specifically unsupervised learning using K-means and convolutional neural networks. And these things can be integrated into an API that allows users to be part of the process. And you can even take this further to build tokens and other integrations into the process as well, such that, maybe people could be rewarded for helping us to tag the collection properly. And I think the coolest thing, and what I would love, this code is already available on GitHub. So technically speaking, anyone can really use it. But I think what would be really cool is really, for other museums to be able to use this model they've developed, this code base they've written, to actually apply to the collection, right? To make all the world's art a lot more searchable and a lot more accessible, like the public good, like an API that it should be, hence the name API.